This is Systems of Linear Inequalities, Part 2. We're going to start by writing a system of linear inequalities for the graph that we have represented here. So we have two lines on our graph, and we also have the shaded shared area that is a solution for both of these inequalities. So any points in this area are a solution for our system of linear inequalities. So we need to start by writing some equations that represent the boundary lines that we have in this graph. So let's look at this boundary line first. It's a horizontal line where all y values are equal to -2. So as an equation for that boundary line, I would write y equals -2. This boundary line right here has a y-intercept of 0 and a slope of 1. It's going up 1 over 1, up 1 over 1. So I would write my equation y equals x. My slope is 1. My y-intercept would really be plus 0, which I don't need here. So y equals x will be my equation. Now both of these equations have equal signs in them. And I know that I'm graphing here some inequalities. So I have to figure out which inequality symbol goes in place of these equal signs. So let's start with this equation. When I look at the line, I see that it's solid, meaning any points on the line can be solutions to my system. Therefore, I want a greater than or equal to sign or a less than or equal to sign in between my y and my -2. Since the values that are shaded are greater than -2 here, my inequality is going to be y is greater than or equal to -2. When I look at my dashed line here, the y equals x, I see that dashed line. I know that things on the line are not solutions to the system, so I'm going to have a greater than or less than sign in between my y and my x. And it seems that everything below this line is shaded, so y is less than x. Now I can always go ahead and test out these points by choosing a point that is in my answer section here. So I'm going to choose 2, 0 right there in the answer section, and we're going to test it out and make sure that our inequalities are true before moving on. So I know 2, 0 is a solution for the system. So I'm going to plug these into my two inequalities, make sure they work, make sure that my answer is right. I'm just checking my work here. So here I'm plugging in I'm plugging in 0 for y, and 0 is in fact greater than -2. So this one works out. This one's true. I'm also going to test it here. I'm going to plug in 0 for y and 2 for x, and 0 is less than 2, so this one is also true. So I picked a point in the solution section. It was true for both of the inequalities I wrote. So here are my two linear inequalities that represent this graph. So let's take a look at another example. So once again, I've got two lines here on my graph, and this shaded section here are my solutions for the system. So I'm going to start by writing my equations for the lines that I see here represented on this graph. So I have a vertical line here, so all my x values are equal to 3. And then I've got this diagonal line here that has a y-intercept of -1, and it looks like it has a slope here where it's going up to and over 3. So I'm going to have a slope of 2/3 and a y-intercept of -1. So now I have to figure out which inequality signs go here in these two equations. So if I look at the x equals 3 line, everything that is shaded is less than 3. And this line is solid, so I know it's going to be less than or equal to. So x is less than or equal to 3. For this line, I have the dashed line, so I know it's going to be a greater than or less than sign. And it seems that everything that's shaded is above the line, so y is greater than 2/3 x minus 1. So I can find a test point just to make sure that my inequalities are true. I'm just checking my work. So I see that 0, 0 is in my solution section. It's in the shaded region, so I'm going to use that as my test point here. So I'm going to plug in 0 for x, and 0 is less than 3, so this one's true when I do my test point. And over here, I'm going to plug in 0 for y, and 0 for my x, and I get 0 is greater than -1, which is also true. So my two inequalities here work. These represent my graph. Systems of inequalities can be represented by two or more inequalities. So let's take a look at this real life problem and see how many inequalities we need to write to represent this situation. So it says you have at most 8 hours to spend at the mall and at the beach. So let's have our x value stand for the number of hours we're spending at the mall. And our y value is going to stand for hours that we spend at the beach. So to write an inequality here, I know that my hours combined have to be at most 8 hours. So they have to be less than or equal to 8. Also tells us that we want to spend at least 2 hours at the mall. So my hours at the mall have to be greater than or equal to 2. They also tell me that I want to spend more than 4 hours at the beach. So my hours at the beach have to be greater than 4. Now they're saying write and graph a system that represents the situation. So I've written 3 inequalities here. So let's graph these one by one and find the areas that are solutions to these inequalities. So let's start with x plus y is less than or equal to 8. So in this case, I can find my intercepts here. If I had x plus y equals 8, I could have 8 plus 0 or 0 plus 8 equal 8. So I've got my intercepts are at 0, 8, and 8, 0. I'm not graphing anything into the negative regions because I'm not going to spend negative hours at the mall or the beach, so I'm only using quadrant 1 here. And I'm going to connect these with a solid line because I have the equals here. Now, if I look at this and choose a test point, if I choose 0, 0, my favorite test point, 0 plus 0 is 0. It is, in fact, less than or equal to 8. So I know that anything in the 0, 0 side is going to be a solution for this inequality. So I'm going to shade this entire area. On to my next inequality. So now I have x is greater than or equal to 2. So my line is going to be a solid line because it says it could be equal to 2. So that line is going to go right here, my vertical line. And I'm going to test and see what works for this line, x equals 2. I'll do my test point of 0, 0. 0 is not greater than or equal to 2. So in this case, 0, 0 is not a solution. So it's everything to the right of this line. So far right here I have an overlapping region, but I haven't done my third inequality yet. My third inequality is y is greater than 4. So I'm going to find my line, y equals 4 right here. And I'm going to test what works for y is greater than 4. I'm going to try that in a different color so it stands out. Oops. And I did make a little mistake here. This should be a dashed line because I don't have an equal sign. So I'm going to redo that. All right, and if I'm going to test anything here, I'm going to test 0, 0. 0 is not greater than 4. So my 0, 0 point doesn't work. It's going to be everything above this line. So I end up with one small section here where all 3 overlap. And darken up that section. It's right in here. It's this little tiny triangle. So anything in that small area right here is a solution to my inequality. So how much time can I spend at each location? So I'm looking for a potential solution. Well, I could find this point right here, which says I can spend 3 hours at the mall and 5 hours at the beach. 3, 5. So this would fulfill my 8 hours. I would be spending more than 2 hours at the mall and more than 4 hours at the beach. It's one possible solution. I know that because it falls in this little triangle here.